Alpinia calcarata Rhizome extracts, a prospective inhibitor of inflammatory mediators by Chandhrakanthan, Kathirgamanathar, Handunnetti, and myself. So I won't be able to ask questions, so I think the audience will have to do my part as well.
Okay, thank you, Doctor. Good morning to everyone. Let's. I'm going to present a part of my postgraduate study, which involves again an isolation of, screening of a medicinal plant to go for isolation and characterization of compounds which have inflammatory activity. So this is my plant, Alpinia calcarata. The most hottest spot of this plant is the rhizome, which has been exported from Sri Lanka for a long time. And I'm going to present on this prospective activity of this against inflammation. So what's so special about Alpinia calcarata? It again belongs to the family of Zingiberaceae, and it's called as He Naratta in Sinhala and Chittaratta in Tamil. And the rhizome, it's used in Ayurvedic preparations in the treatment of rheumatoid arthritis and various other activities. And so many activities have been already proven on this plant, including anti-inflammatory, anti-nociceptive, and anti-diabetic properties. So what is more important on this plant for this anti-inflammatory activity is there was a clinical trial by Professor Tabru in 2003. It shows like 3 months treatment with this Maharasnadi Kota, which is a traditional preparation. It improves the inflammation-related pain and mobility of the affected joints. So that Maharasnadi Kota, it has 80 grams of Alpinia calcarata rhizome and 25 other plants. So this Alpinia calcarata has something to do with the inflammation. So there are other studies have been done using this plant extract. It includes the carrageenan-induced rat paw edema model, which is a rat model for the anti-inflammatory activity, which is for the acute inflammation. But there are no reports available for the anti-inflammatory activity of these rhizome extracts on nitric oxide production inhibition and membrane stabilization. These are other pathways in which one of my friends, she has explained earlier. There are so many pathways related to inflammation, in which these two also has some significance. So what is NO? It is a free radical biomessenger, and it is a product of oxidation of this cycle, L-arginine to L-citrulline. So there are 3 consecutive forms like constitutive, neuronal, and inducible. And so the negative thing regarding this nitric oxide, it aids in pain. So even though it has some gain, it has so much of pain when the level of the nitric oxide increases. And when you see the rheumatoid arthritis patients, you can see 2.5 times of nitric oxide than the healthy individual. So here are my objectives. We have checked the cytotoxicity of this plant extract in the raw 264.7 murine macrophages, and then we have checked the pattern of nitric oxide inhibition, and we have also analyzed the red blood cell membrane stabilizing ability. So this is how our study has been started. We have collected the plant material from the western province of Sri Lanka, and we have followed 2 kinds of extraction. It is by one by hot extraction and another by cold extraction. This is to see which method of extraction has we can go forward to isolate more amount of compounds. So I have done the extraction using the following solvent. Starts from the non-polar to the more polar, methanol, and then the water. So the extracts have been vacuum dried and freeze dried. So this is my model. We have induced the raw 264.7 macrophages using this LPS, in which it transcriptionally activates this iron OS to produce nitric oxide. So once you target this transcriptional activation, it will be a key for the drug discovery, because it completely affects the inhibition. I mean, it completely aids the inhibition in the gene level. So this is not scavenging of a free radical biomessenger or something. It is like inhibition of its production. So we have checked the cytotoxicity using the MTT colorimetric assay. We have incubated for 30 minutes and then followed by the MTT assay, and then later the nitric oxide inhibition using the GRIS assay. We have treated them for 30 minutes using the following concentrations, and then we have induced with the LPS, and then the later absorbance was carried out. So here's the method for the hemolysis assay, in which we have prepared the RBC suspension and then treated with the plant extracts, and again we have treated them under 54 degrees C for 25 minutes, and then later the absorbance was carried out. So the most interesting results. So we have checked the percentage viability. We don't need the cytotoxic level. I mean, we need the cytotoxic level, not the toxic concentration. So we have checked the highest concentration, 500, and the lowest, and even we have gone up to microgram, even the nanograms level, but those were not showing any cytotoxic. So I have shown the highest concentration, in which the 500 microgram level, it has shown 50% of viability, whereas the 250, it has shown more than 80%. So for the assays, we can take only the viable concentration, since we have to go further with the nitric oxide assay. So the absolute concentration we have chosen is 250, and so this is the pattern. Even so many people have shown the control cells which are fine in the morphology, later the apoptotic stage, and later that is the 500 microgram. In the 250 microgram, the cells are again, they are fine and they are growing. So this is the nitric oxide inhibition pattern by these Alpinia calcarata extracts, in which the petroleum ether extracts show the maximum inhibition compared to the control. Even the control shows 89%, whereas the petroleum ether hot extracts have been shown 88%, whereas the DCM and ethyl acetate extracts also have shown more than 50% inhibition, whereas the hot extracts like methanol and water, the hot extracts of the polar solvents like methanol have shown less than 30% inhibition. So we can see the difference, like hot extracts are more suitable for the further process of isolation, whereas the cold is behaving in a slow manner. So this is the inhibition of heat induced, in which we can see the same pattern. The hot extracts, which are shown in the orange color, they have shown a greater inhibition compared to the control, whereas the cold extracts are a bit less than the hot extracts. So this is the dose response relationship of the most active petroleum ether rhizome extracts, which are again the hot extracts, on the nitric oxide production inhibition. The first graph, it shows a dose response relationship, in which the highest concentration shows the maximum inhibition of nitric oxide production, whereas in the inhibition of heat induced hemolysis, it's also followed a pattern of dose response. So the IC50 values are mentioned. So I just want to conclude by saying that nitric oxide inhibition and membrane stabilization potential of this Alpinia calcarata Rhizome extracts have been shown in a promising way with less or no cytotoxic concentrations. Among all extracts, the hot extracts are the most active, and it can be concluded that in a futuristic way we can isolate the active compounds, and we can have a standard of those compounds, and those can be the further future study. So the present study also validates the anti-inflammatory activity of these Alpinia calcarata Rhizome extracts. I would like to acknowledge my granting partner, National Research Council of Sri Lanka, and thank you everyone for your patience and listening.
The paper is now open for discussion. I expected the audience to do my part as well. So it seems to be very clear, is it? Okay then, thank you very much.